Hello students, welcome to this lecture number 7, and this will be the last lecture in this chapter, that is the compound having the nitrogen atoms. In the previous lectures we have discussed about regarding the amines, different reaction process and different preparation process that we have discussed in detail. Now that is the second compound that we are going to discuss in this lecture, that is the diazonium salt. So heading of today's lecture of diazonium salt. So in this lecture we are going to discuss the diazonium salt. This is Kwaji in the science wing YouTube channel. First let's understand what is basically diazonium salt. Is the general formula of this diazonium salt is general formula is R into X. R stands for, here R is basically the aryl group. N2 stand for diazonium group. And X minus stands for anions. These anions may be halide ions, it may be a halide ion, is maybe hydrogen sulfate ion, it may be BF4 minus ion. So this is the things. Now how do we name the diazonium salt? It is basically named by suffixing the diazonium with the parent hydrocarbon from which this salt is prepared, and it is followed by the name of the anions. As for example, C6H5N2CO. So here name of the hydrocarbon is benzene. So we write benzene and it will be suffixed by diazonium. And followed by the anion. Anion is here chlorine. So chloride ion. So benzene, diazonium, chloride. As for example, this HSO4 minus. This is benzene, diazonium. This is benzene, diazonium, hydrogen sulfate. Okay, so in this way we can able to name diazonium salt that is prepared from the aliphatic amine is not so stable, but the diazonium salt prepared from the aromatic amines, primary amines, that is aniline, it is much more stable than this, but its stability is not so much. It only stable at the solution stage and at the lower temperature. So when we are going to use this diazonium salt, because diazonium salt you will find that it is a very good intermediate for any other different types of organic compounds. So as soon as it is been prepared, you have to use it. We cannot able to store it. The question arises that why that diazonium salt prepared from the aromatic primary amines is stable, whereas the prepared from the aliphatic primary amines is not stable. The reason behind this is that diazonium ion, arene diazonium ion is cations is very much stabilized due to the dispersal of the positive charge through the ring, that we can easily see from the resonance structure. This is the diazonium ion. And here what is going to happen, this electron pair, loose pair electron is go there and it is going to make a resonating structure like this. Here this electron will be going to here and this is being, and here you can see this positive charge is here. Again this electron, loose electron, pi electron will go there. So what we find, this positive charge has been delocalized through the ring, and that is why it is much more stable. Now we are going to discuss the preparation of diazonium chloride. Preparation of diazonium chloride. It can be prepared from the aromatic primary amines by the reaction with the cold NaNO2, reaction cold solution of sodium nitrate in the dissolved solution of the primary amine. That is, the reaction is this. This is the primary amine, that is here taken aniline, that is react with NaNO2 and HCl, and here it has been prepared C6H5 into Cl plus NaCl and H2O. This is the reaction 2 and 2. This is the balance reaction. So you will produce this diazonium salt. During the diazonium reaction, this is called the diazotization reaction. This reaction you require the more amount of the acid than the amines, because one molecule is acid is required to dissolve this amine, one molecule acid is required to produce the nitrous acid, because during with the reaction with the NaNO2 and HCl, nitrous acid will be produced, and one molecule is required to maintain a proper pH of the solution, because if you do not maintain the pH, then again there is a reaction that we will discuss later on, that is the coupling reaction will going on with this diazonium salt, produced diazonium salt and this amine. So 3 moles of HCl, that is the acid, is required during the diazotization as compared to the primary amine. Okay, so we understand how we can able to prepare the diazonium salt. Now we are going to discuss the physical properties. Physical properties. Physical properties of the diazonium salt is, it is a colorless crystalline solid and it is highly soluble in water, and in the solution it is found in the, there is a stability. And another thing that was mentioned, not mentioned, that is we have to maintain a temperature to 73 degree, 73 Kelvin to 278 Kelvin. Very low temperature we have to maintain for this reaction, and it is stable at a very low temperature in the solution stage. In the dry state it is going to be decomposed. Another diazonium salt, that is benzene diazonium fluoroborate. Benzene diazonium fluoroborate, this compound it is insoluble, that we will discuss. It is also very important compound. Benzene diazonium fluoroborate, C6H5N2BF4. So this diazonium, that is this diazonium salt, is not soluble in water, but it is stable at the room temperature. So now we have discussed the chemical properties. Chemical properties, that is divided into 2 parts. We discuss the chemical properties. Chemical properties. Chemical properties has been divided into 2 ways. Number 1, that is the replacement of diazonium group. Replacement of diazonium group, right? Second, retention of the diazonium group. Retention of diazonium group. First we discuss the replacement of the diazonium group. Replacement of, we can say, N2. In this process, what is going to happen? The nitrogen in the benzene ring has been replaced by some nucleophiles like halides ions, like cyanides ion, iodide ion, fluoride ions. Those are very good nucleophile, but normally benzene do not able to undergo this nucleophile reaction because it is an electron rich species. So when it is an electron rich species, it cannot able to accept a nucleophile. But nucleophile can be incorporated to the benzene ring with this process. That is a very, very important process, and with this you can easily understand how useful this benzene diazonium salt is that it can be able to produce many compounds that normal chlorination or iodination or fluorination cannot be able to produce. That is why this is a very important compound. So replacement of N2 group, in this process diazonium group is a very good leaving group, so it can easily be removed and replaced, substituted by other group. That is that we are going to discuss. First, that is the replacement with the halides, replacement with halide ion. So we can write it replacement with halide, replacement with halide, replacement with halide and cyanide. Here also there is a two reaction that you can see. One, that is the Gatterman reaction. One that is going to, that is the Gatterman reaction. Gatterman reaction. Gatterman reaction is here in presence of copper powder. When halogen acid is reacted with the diazonium salt, it is going to replace the appropriate halogen. As for example, this is a diazonium salt. And with HCl and copper powder. HCl and copper powder, it is going to produce this chlorobenzene. But another reaction, C6H5 into X minus, it is going to, with the HBr, suppose HBr and copper powder, it is going to produce the C6H5Br. Another reaction that is we are going to discuss, that is Sand-Meyer reactions. This is a very important reaction, Sand-Meyer reaction. Sand-Meyer reaction. In this reaction, here also you can see that is the replacement of the diazonium group by the halides and cyanides. And the reaction is taken place in presence of Cu plus ion. So reaction is this, C6H5 into X, Cu2, Cl2 and halogen acid, and it is going to, here also you can see nitrogen has been revolved. Nitrogen as a gas is revolved, and another product will be formed, that is, suppose this is CuX or CuX. CuCl2 and HCl, that is, you can able to see again the chlorobenzene is and N2. C6H5 into X, Cu2Br2 plus HBr. So here also you can see that bromobenzene is prepared. Okay, and another reaction that we are going to discuss, that is C6H5 into X minus, that is CuCN and KCN, and it is going to produce the CuCN plus N2. So these are the Sand-Meyer reaction. Sand-Meyer reaction is much more important because it has a better yield than the Gatterman reaction. Now the replacement, we can also replacement iodine. Replacement with iodine. Iodide ion. Replacement with the iodide ion. In this case, what is going to happen? The C6H5N2Cl, when it is heated with the potassium iodide, it is going to produce iodobenzene. It is going to produce the iodobenzene. Replacement with fluoride ions. Fluoride ion. In this case, first we have to react this diazonium salt with fluoroboric acid, and this will going to produce thus benzene diazonium fluoroborate, and when we heat this, it is going to produce the aryl fluoride plus BF3 and N2. Okay. Now replacement with H, hydrogen. In this case, the reaction is carried out in presence of the very mild reducing agent, that is hypophosphorus acid or the ethanol. So this reaction is this. Air stands for, that is your aryl group, benzene ring, that is where it is general form. When it is react with hypophosphorus acid, and it is going to produce a reducing agent, and it will oxidize this. It is reducing agent to reduce this diazonium salt into the arenes, that is into the hydrocarbons, and it itself will oxidize to hypophosphorus acid, N2 and HCl, HX. With ethanol, it is again produce the hydrocarbon arenes, and it will itself reduce in the HCl, N2 and not HCl, HX and HX. Again, the replacement with OH. We know the diazotization reaction is carried out in a very low temperature, but if we increase the temperature, then the warm water that will going to produce the phenol. In this case, you are taking, suppose this is diazonium salt, and diazonium salt is with the water, it will going to produce the phenol. Now there is a reaction where we can able to incorporate the NO2 group in the benzene ring, that is replacement with NO2 group, replacement with NO2 group. In this case, first this reaction is carried out to produce this HbF4 butyric acid, and it is going to produce C6H5N2BF4 minus, and then the solution of NaNO2 in presence of copper, it is going to produce this NO2. That is the nitrobenzene we can able to produce. These are all the reactions that is concerned with the replacement of the diazonium groups with the other groups. Now we are going to discuss the very important reactions where we will retain this diazonium group, and this is called the coupling reactions. We are going to discuss the coupling reaction. Coupling reaction, it is nothing but the retaining of the diazonium groups. This is at the pH 9 to 10, that is at the basic medium, it is going to produce this product. This is where you can see the diazonium group has been retained. And this is para hydroxy azobenzene. This is para hydroxy. This is with the anilide, and this reaction is taken place. The reaction is taking place in, that is the pH 4 to 5, and it is going to produce this is para amino azobenzene. This is para amino azobenzene, and this is the reaction is taking place in the pH 4 to 5 acidic pH and here pH. So that is all for today's lecture, and this is the last lecture. In this lecture we have discussed about the diazonium salt, the different aspect of the diazonium salt that is in your syllabus. First we have discussed about its nomenclature, then we have discussed about its physical properties, then chemical properties. Chemical properties basically divided into two parts. One that is the replacement of the diazonium group, and another that is the retention of the diazonium group. That is a coupling reaction. This is a very important reaction that you can see, that is here the different type of product has been produced, which is colored, basically used as a color. Here para amino diazobenzene, it is color is yellow. So that is all to this lecture. That is thank you for watching this lecture, and we will meet in the next lecture with different topics. Thank you.